Good morning, citizens of New Zealand. On December 4th, the Soviet Union, Iran, and Japan were hit with nearly 30 nuclear weapons. This attack prompted a series of retaliatory strikes from all nuclear powers of the world. The events of yesterday have left a heavy toll on those of us who are left. As the Prime Minister of the great nation of New Zealand, I am here to say that we have survived nearly unscathed. The major powers have underestimated the importance and defensive capability of New Zealand. The United States, Soviet Union, Europe, and much of Eastern Asia have been reduced to a lawless wasteland, rife with starvation and radiation sickness. New Zealand must be the one to extend a hand to those affected by this terrible war. As I speak, scientists from the Soviet Union and American space programs are making arrangements to join our own agency. It is clear now more than ever, New Zealand will be the nation to guide Earth forward into the stars. And now we bring you the World News broadcast. Our top story tonight is that the United States has lost control over many of its central regions, and several countries in the north are proposing to join Canada as a means for economic stability. Many surviving politicians are almost certain that the situation can be resolved without violence. In other news, Spain, Turkey, and Sweden are being flooded with refugees suffering from long-term radiation sickness, which is overwhelming their hospital systems. Our Prime Minister made a statement this morning assuring that medical aid will be supplied to surviving European nations. That is all for today. Glory to New Zealand. Welcome back to the New Zealand Space Agency. I took a lot of time making those last updates, so I hope that was something new to mix it up a bit, because clearly my rocket science is starting to lack a little bit. So I'm just gonna look at YouTube videos and stuff to try to find designs for rockets that I can steal, because I'm not smart enough to do it on my own. Well, I might be, but it would take me too long, so, you know, whatever. First order of business, we've got a lot more money now. So let's go ahead and look in the upgrades for quite a few different upgrade points. I'll save 200,000. Right. Let's pump one more into R&D, and then I will do... I'll split it. I'll put 4 in here. And 2 in here. And so now, if I look at our tech, early avionics, only going to take 150 days. So we'll be getting into 1960. That shouldn't be too much of a problem, since I'm actually going to, today, start designing a new rocket. Because if you didn't hear... Hello. If you didn't hear last time, the Soviet Union and Americans are sending any of their surviving rocket scientists towards New Zealand. So we're going to have a lot more ideas. Let's go into the vehicle assembly building and see what we can work with. So this was our last rocket. I think I'm actually just going to make a whole new one, because the Legolas series of rockets is about time to be retired. Yeah, let's go ahead and start making a new rocket.
The act of moving onward means we pass these signposts. One of them was first leaving Earth. The next one is hanging out on the moon. What's next? The planets. Onward to the edge. We're moving onward to the edge. Here we are together. This fragile little world. This fragile little world. Onward to the edge. We're moving onward to the edge. Here we are together. This fragile little world.
This is our song. Just another star in a sea of stars, the heart of the solar system. Just another star in a sea of stars. Mercury is the closest planet. This tortured piece of rock has been stripped naked.
The moon has a sky, it has a horizon, it's another world. It's got Earth in the sky, just the way we have the moon in the sky. Onward to the edge, we're moving onward to the edge. Here we are together, this fragile little world. We're not the only world to think about. Worlds unknown. We're not the only world to think about. Think about worlds unknown.
There is a powerful recognition that stirs within us. When we see our own little blue ocean planet in the skies of other worlds. A powerful recognition that stirs within us. When we see our own little blue ocean planet in the skies of other worlds. The Saturn system offers splendor beyond compare because of its rings and very diverse moons.
These are no longer abstractions. These are worlds. Maybe there's life there. They've changed how we think about Earth.
Our own little blue ocean, our own little blue ocean planet.
A mote of dust suspended in a sunbeam, the pale blue dot.
Onward to the edge, we're moving onward to the edge. Here we are together, this fragile little world. This fragile little world. Onward to the edge, we're moving onward to the edge. Here we are together, this fragile little world.
And there we have it. I have yet to come up with a name for this launch vehicle, but the weather satellite for the payload is just going to be called WeatherSat. Because that seems simple enough, and I'm not going to launch too many of these. So, you did see the construction, but just want to go over these tanks that I'm using now are a lot lighter than the old ones, so we are able to get by with more Delta V than with the previous rocket. And the payload is actually it's a lot bigger than, sure, it's something to compare it to. Anyway, it's a lot bigger than the old one, so it should be able to get somewhere. The interstage has the same engine with an engine upgrade, another balloon tank, and an avionics core to control this section of the rocket once it gets into orbit. And then this massive thing with an upgraded LR-79 engine, which packs a lot of Delta V. I need to fix the staging, but
this, it's a cool rocket. I don't think it's based on anything in particular, but we have American and Soviet engineers now, so I can take design inspiration from some of their rockets if I need to. Anyway, that's a pretty good rocket, if I say so myself. And here we have the Koha 6 in orbit of the Earth. It's starting to collect a lot of science from all of its instruments. It's spinning quite wildly, but at least I got it into orbit. This should, in the sunlight, it's nearly perpetual power, so it should last, maybe not 90 days, but at least a good portion of that. And that'll get us a lot of science for the space program that we really need at the moment. And then I think the next shot would be towards the moon, if I'm not mistaken. And actually, by the looks of it, our power is indeed perpetual, because it was at 98%, now it's at 99%. So this probe will stay up indefinitely, that is until the solar panels degrade, but we don't have to worry about that right now. Right, up to 7.7. We get lunar range communications at 7.8. That's our first goal. I mean, we get lunar range communications at 8 science. That's how much it costs. I think there was a radiation storm that appears to have damaged the batteries on the probe, which does happen unfortunately, but we're still getting a lot of data from this. We have collected 12 science. It's going to keep giving us some more data. So let's go ahead and get back to the Space Center. Alright, we're here at the tech tree, and lunar range communication I think is the only one that we can afford at the moment, but that's fine because we do actually need it. Especially because it gives us this new antenna, and then we can finally upgrade the tracking station. Nice. Get a bunch of new stuff, and now we can even finally upgrade our tracking station. No, never mind. Oh, we need to actually research. I guess that makes sense. But the good thing is it's only going to take 142 days because I have poured even more money into our research. So, we need a lunar probe. And I'm going to start with our avionics. design a probe and then stick our rocket on the bottom of it.
Say, do you like mystery stories? Well, we have one for you. The concept? Relativity. That strange, fantastic relationship between time, distance, and math. Before we're finished, I think you'll agree that truth is stranger than the strangest fiction.
Why do the stars shine? Why does the galaxy light up?
E equals mc squared.
That is the engine that lights up the stars. Energy turns into mass.
E equals mc squared.
That is the secret of the stars.
That is the secret of the stars.
Now listen carefully. The faster you move, the heavier you get. The energy of motion turns into m, your mass. Energy of motion.
Energy equals mass times the speed of light squared. An awful lot of energy for a tiny amount of mass. Light travels at the same speed, no matter how you look at it. No matter how I move relative to you, light travels at the same speed.
No matter who is doing the measurement, and no matter what direction you are moving, the speed of light is the same. The speed of light is the same, no matter what direction or how fast. As you travel faster, time slows down. Everything slows down.
Time slows down when your time passes at a different rate. Clocks run slow.
It's a monumental shift in how we see the world.
The beauty, the majesty, the power of